So there has to be a better way. I mean, there is a better way to deal with that, but it still remains a recommendation. Now, there is a warning I need to let you know about. The concept of information hiding is that if you want to enforce all the programmers to not access particular data, so that you have kind of control over who accesses the data for maintainability. And in Java, you can do this with the private keyword. Remember that? So when you define an attribute, you set it as private so that it wouldn't be accessible unless you allow to. It's accessible only through the class. Now, it's not properly implemented in Python. There is a claim. There is a claim that when you define a variable with 2 underscores in its name, like this, it will not be accessible. And this is partially true. This is only partially true. It will not be accessible to read. If you try to read it, it will say, I don't know anything called underscore ID. But if you try to write, just like you wrote the salary, it will define a new attribute, not the original one, with the value that you try to enter. So if you look internally, this is the original one here. Now the way we hide it is just we add a prefix to it, as if like this is very clever, so now nobody's gonna know the prefix, so nobody's gonna try to read it. Yes.
What if you actually prefix as well?
It's accessible then. So if you try to read it with the prefix, it is accessible. So it's not completely hidden, it's just kind of camouflaged a little bit. Okay? But what is really dangerous is that when you try to read the underscore ID from inside the class, it will see this value, even though you added another attribute with the same name. Okay, so let me show you this, just in case you encounter that. It would be very difficult to see. So let's say we have underscore ID. That is initially, let's say, I'm gonna give it a value just to see the difference. Okay. Now I'm gonna try to print this ID here. So print imp1 dot underscore ID. Now if I try to do this, it will give me an error saying, hey, there's nothing there called ID. Okay, but if you happen to write it before you read it, like this. So let's say this is 4, 5, 6, 7, 8. It will print it with no problem at all. Now, you know what is different? What is really even more dangerous? Now, if you look inside, there is something that was a representation of that ID that still have the 1, 2, 3. And then there is another thing that has another value. Now, if you are inside the class and try to read this underscore ID, so let's say I'm going to define a function inside the class. Okay, so the way we define functions, diff, and then the name of the method, so let's say print ID. And I'm going to explain what is this self in a bit, but this is how we define a function. Now I'm just going to print the underscore ID without the prefix. Okay, I'm going to explain. This self is like this keyword in Java. Okay, I'm going to explain it in a bit. But there is something that is accessible inside the class with that name. Okay, now if I just try to call this function, so from imp1 dot print ID, and I'm going to stop right here. Now see what's happening. So if you are working inside the class, writing code inside the class, you refer to that variable. it has a completely different value than the value that you may have set when you call it outside of the class. Okay, so that's just a warning for you. There is that claim that under like adding 2 underscores as a prefix of a name make it private or is implementation or information hiding is not true. Okay. All right. Now let's see, we need constructors, right? Now usually when we have a class, we can have multiple constructors. You've worked with that in Java, right? Now how do we define constructors? We don't define constructor the same way we had in Java with a function with the same name of the class, even though this is how we call it. So this is how we call it here. But internally, we don't define this function. This function is defined automatically behind the scenes. And inside of it, it calls a function called init. So there is a built-in function whenever you use a keyword class. Internally, there is a function called init surrounded by double underscores. So this is where the initialization happens. Now, if you want to create different variations of the constructor, you can define variations of the init function. Okay, so now internally, there is a default one that doesn't take anything other than the self. We will see what this self means. So I'm just going to remove this. Don't do it, okay? Now I need to define my employee because I don't like this initialization that is meaningless. I want to allow whoever creates the object to initialize it. So I'm going to define the function called init, surrounded by double underscores, that must take at least one parameter that in the convention is called self, okay? But this is a variable name. You can call it whatever you want. So it's just the location, the first parameter is what represents the self or what is referred to in Java as this keyword. Okay. And then internally we can just say pass. Now pass this keyword string, it's like an empty block. Okay. Now let me show you what does the self mean. So when you create an object here, if you were in Java, there would be a keyword called this internally that would point to its own address. So it would be pointing to 1, 2, 3. Okay. Now in Python, it's not restricted. It's not a restrict keyword. You can call it whatever you want. You can call it this. You can call it self. Call it whatever you want. Convention. Most documentation, when you look at the documentation, you will see that it is called self. So we're gonna use that convention. So when you refer to a variable self, you are referring to or using a variable that points to the object points to its own address. So here, the variable self in this object will be pointing to its own address 456. Okay. So when we define a method inside a class, we must at least have this one parameter when we define it. Okay, but we are using this to initialize the values of the attributes. Okay, so we should expect it to receive something for the name and something for the email. Now, even though I'm using the same variable name, this name is not the same as this, right? And this email is not the same as this one, right? You're familiar with that, right? This is local to the function, and these are the class attributes. So when we receive these values, we use them for initialization. So I will use the object reference self and then name, so that I'm referring to that class attribute, and then I would initialize it with the value that's coming as a parameter to the function, right? And then again, I will define self.email, and then I will initialize it with the value coming in the function. Now, we do want some employees to have salaries, so we can do this self.salary, even though it is not defined in the class level. I can just add it here, like this. All right, so these two had were defined in the class level, so we had initial values, default initial values. This one was added eventually. So let's look at the employee one when it was defined. How does it look like internally? Oh, sorry. Now that I overrode the default init, I need to send some values for initialization. Okay, yes. So you see in Python, you can have optional parameters, right? So you cannot have overloading. You can, if you want some of them to be optional, you just provide the initial value. I mean, default value like this. So in that case, email will be optional. Okay, so instead of initializing values like this, I'm gonna send them as parameters, as arguments to the attribute, to the constructor. Now see, what am I doing here? See what is happening here? Remember when we said that the number of arguments must match the number of parameters? How many parameters do we have here? 1, 2, 3, 4, right? 4 parameters. How many arguments are we sending? 1, 2, 3. How is that not a problem? Now, the init function is called internally, and it automatically, I mean, the interpreter automatically sends the object address in the first position. Okay, so we don't get to send it from here, it will be sent automatically. So we only start with the arguments that are meaningful to our object. The self parameter, we don't have to send it, it's sent automatically. So if I run it like this, now if I look internally at the object, I will see that the email and the name and the salary are there. Okay, now once we define, we do similar work with the other employee, we can also have salary for it. But if I want to make it optional, I can just give it a default value like this. Okay, so in that case, I can use different versions of the employee. All right, so if we discourage people from trying to initialize the values outside using by accessing the variables altogether, we provide some consistency with the objects, even though it's not enforced, but there is some consistency there. Okay, now notice that there is no difference between the name and the email that were defined as part of the class and the salary that was added, right? So it is also a recommendation that unless there is a meaningful initial value that you need to set it whenever you create an object like this, then there is no point of having that class level attribute defined. Okay, so that would look exactly the same as this one once we run it. So if I stop this and rerun it, there's no difference at all with how it is internally presented. Okay.